We need some like that. What?
I don't think anyone knows what you're talking about.
What's the song?
Basic differentiation rules and rates of change. Today we find out the second thing that derivatives do for us, one of which is, in other words, the thing we already learned about a derivative is that it is the slope of the tangent line to a curve. Very good. Today we'll get the second thing, which is it's a rate of change. We'll get to that later. A lot of things you need to be able to do in this section. I think I got 2 pages of you should be able to. Find a derivative using the constant rule. You'll like this so much. No more f of x plus delta x minus f of x and then take the limit. We've got some shortcuts. Got a lot of shortcuts. We got a power rule. Got a constant rule, got a power rule. Got a multiple rule. I read that wrong. The constant multiple rule. I got a multiple rule too. That's coming up. The sum and difference rule. I think multiple rules next. It's in here somewhere. Sine and cosine. Rate of change.
Somebody needs to change this.
Third thing for our derivative, velocity. So then we'll be done. Okay, then we can just relax for the next couple months. Yeah, there's a multiple rule too that we'll get to. I think it's on, never mind. Constant rule. What is the derivative of a constant? What's the derivative of 2? Let's think about this. Let's suppose we have a constant, I don't know, 2. What's that graph look like? Can't remember horizontal or vertical, so you just wave your arm back and forth. It's a horizontal line. What's the slope of a horizontal line? 0. So what would the derivative of any constant be? 0. Oh yeah. Whoa, a little fast there. Get your trigger finger. I'm going to switch up the notation a little bit to keep things fresh. I went with the Leibniz notation there. The derivative of c with respect to x, the derivative of a constant with respect to x would be equal to 0. As I've said a number of times, I'm not a big fan of memorization. You could just memorize all these rules. It won't get you very far. It's important that you understand why this is equal to 0 because, like I said, a constant would be a horizontal line. The slope of a horizontal line is 0. We're good to go. Let's move on. Good? Uh-huh. All right.
Wait, I didn't come down that equation.
D over dx parentheses c equals.
You still help.
Got it.
We're solid?
Yeah.
Good. Okay. So a couple examples here. The derivative of the function 7 is 0. By the way, I wouldn't write these examples down because you'll see it pretty much beating a dead horse here. The derivative of 0 is 0. The derivative of -3 is 0. The derivative of pi squared is 0. Okay, remember pi is a constant, it's a number. That will get some of you at some point in time. There are a couple other things that fit into that same category, like E. Remember, E is a number, not a variable. 2.718281828 459.045. You all had that number memorized, right?
Sure.
Weak sauce.
That means I as well.
I'm sorry?
Would I work?
I is imaginary, and we don't talk about imaginary numbers in here. Let's watch your mouth. Okay? We are in a real number system. This isn't Easter Bunny math.
Why do we learn the same numbers?
Did I ruin that for anybody? Are we good?
What?
Nothing. Nothing. Never mind. Moving on. Power rule. There's a term in Latin, ad nauseum. Do you know what that means? Loosely translated, ad nauseum means until you puke. You will do the power rule ad nauseum. It is the bread and butter, the meat and potatoes of derivatives. It's going to seem fairly intimidating, but it is ridiculously simple. Here it is. By the way, this is really important. Here's the calculus speak. You want to write this down? You don't need all this other fancy stuff. You know, it's differentiable. Well, we know it's differentiable. We're taking a derivative of it. Duh. And then I'll show you how that works in a second. Well, actually, you tell me. Let's do the translation. What does this mean? We're taking a variable raised to the nth power, and when I take the derivative of that, what do I do, Taylor?
You multiply it by the number that's in the exponent, and then you take one off the exponent.
Well said. Did you get that? Bring the exponent down, reduce the exponent by 1. You're
so
done.
We can read that whole part down there just for
Yeah, it's like on the drug commercials when the person tells you all the possible things that could happen to you if you actually take the drug that's supposed to help you. That's kind of what this last sentence is. Yeah. You take a drug for itchy skin, but you could have a stroke or run over by a bus or develop heart condition. Some people taking these drugs have gone crazy, that kind of thing. It's the same thing here. It's like the weird stuff that could happen. Okay, so what's the derivative of x cubed? While you're thinking about this, and while I'm getting my pen ready, consider if we had to do that using the methods we talked about yesterday. You would have to take x plus delta x, cube it, minus x cubed all over delta x, multiply that beast out, cancel things, take the limit, you get your answer. However, what is f prime of x? 3x squared. Yes, it's just that easy, kids. Bring the exponent down, reduce the exponent by 1. This is going to be a pain in the butt. So I got to click back here, then advance. Yeah, okay, good. Then I come back over here and click, and that's written right over that. What's a derivative of x, of the cubic root of x? G prime of x is equal to. A lot of blank stares. Hold on. Let's do something first. And I don't mean cry. Let's rewrite g of x. What would be a logical way to rewrite g of x? X to the 1/3. Hot diggity. Now, what's g prime of x? 1/3 x to the negative 2/3 power. Because 1/3 minus 1 is negative 2/3. Pregunta.
Can we leave that that way, or do you want us to?
Ooh, great question, Claire. You're not going to like the answer. Well, I was going to tell her anyways, whether she asked her or not. No negative exponents in your final answers. 2 things to remember in calculus. No negative exponents, no fractions within fractions. So how do I change that so it's not a negative exponent? Lucas?
1/3x raised.
Just erase it, right. X to the what, I'm sorry, somebody? 2/3. Done. Just move it in the bottom. It's on the bottom. If it's on the top, move it to the bottom. If it's on the bottom, move it to the top. Lose the minus sign. Andrew?
This was so simple. How come we got so many?
Because you got to understand how all the puzzle pieces fit together. And some chowderhead is going to ask you to use the formal definition of derivatives. Yeah, it's going to be grassy. He's going to just pop in out of nowhere and ask you for the formal definition of derivatives. All right. H of x. Well, again, let's rewrite h of x as... Nope. X to the negative 2. Gazoon type. Therefore, h prime of x is equal to. Pastel pinged?
No, it was iPad. I'm copying down the
Oh, you didn't ping, your iPad pinged.
Yeah.
That would be weird if that noise came from a human.
Probably.
You might want to go see the nurse.
I'll look in.
Okay, good. No, I mean, if you pinged, you didn't ping, you'd have to go see the nurse now, we know it didn't come from you. Go ahead.
1 over 2x.
I'm sorry?
Would it be 1 over 2 negative 2x?
Would it be 1 over negative 2x?
1 over negative 2x.
I think we maybe went over negative 2x.
Negative
to the
2x.
third.
Let's take it in stages here. Bring the exponent down. Uh-huh. Reduce the exponent by 1. Negative 3.
Negative 2 minus 1 is not negative 2.
I'm sorry?
I was just, don't worry about it. I got it.
Okay, I won't. Negative 2 over x cubed. Because again, we don't want negative exponents. Are we having fun yet?
So much.
Good. You should be, because this is a lot easier than doing the other method.
Oh,
Oh wait, I gotta go back here and erase. Da, 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 ba, ba. Constant rule.
Is it the constant?
I'm sorry?
Do I write multiple, or is it just the constant?
You can write whatever you'd like. It's a constant multiplied. It's really simple. If you have a constant multiplied by a function, then take the derivative of the function and multiply by the constant.
Did we already do a constant rule? Yeah.
No. Oh yes, we did a constant rule, not a constant multiple rule.
So you should write multiple.
Okay, yes. You ran circles around me logically. Well done. So what happens if there's a constant out in front of, let's say, x squared? What's the derivative of, let's suppose f of x is 3x squared. What's f prime of x? 6x. Well done. If you don't see that, it's simply rewriting this as 3 times x squared. Take the derivative of x squared, which is 2x times 3. Oh, that's bad. That shouldn't be there. So now if there's a number out in front, a constant, you bring the exponent down, multiply it by the constant, or the coefficient if you prefer, reduce the exponent by 1. Okay, so I would prefer to call this a coefficient rule, but the technical name is the constant multiple rule. Okie doke. What's the derivative of 2 over x? Well, if it's not something pretty, I'm going to start by rewriting it. How do I rewrite 2 over x to make it more doable? 2x to the negative 1. Therefore, y prime is? Negative 2x to the negative 2, which is negative 2 over x squared. F of t. Well, I'm going to start by rewriting f of t as 4/5 times t squared. Therefore, f prime of t would be say what?
8/5 t.
Well done. 8/5 t. Multiply the constant by 2. 4/5 times 2 is 8/5. Reduce it by 1. How would you rewrite c? Max? Give it to me again.
2x raised to 1 half.
Okay, so y would be 2x raised to the 1/2. Keep going, Max. What's the derivative?
Then it would be. Hold on. Correct on the question.
I don't.
Do you need parentheses or anything?
Oh, wait. Oh, just 1 over. No.
There's more than that.
To the negative 1/2.
Say again, right?
X to the negative 1/2.
X to the negative 1/2. 1/2 times 2 is 1. Reduce the power by 1. 1/2 minus 1 is negative 1/2, which then becomes 1 over x to the 1/2. Or if you're feeling saucy, 1 over the square root of x. Same thing. D. How do you rewrite that bad boy?
2x to the 2/3.
I see what we got? Right, Terry?
1 over 2x.
1 over 2x to the
2/3.
2/3.
Which
Whoa.
1/2.
We don't know how to do that yet. Go ahead. Somebody's talking.
1/2 x and then negative 2/3.
Well done. Here we need to put the negative back in there so we can take the derivative. So therefore y prime is
Negative 1/3.
negative 1/3 x to the negative 5/3, which is negative 1 over 3x to the 5/3. You can see how it gets a little bit more complicated. Yo!
I just want to make sure I'm understanding this. So to
Okay.
get the number out in front, you have to multiply it by whatever number's out in front of the function? Like,
Yes,
you
the
multiply
coefficient.
Yeah, so, okay.
Yeah, so I multiplied negative 2/3 times 1/2 to get the negative 1/3 and then reduce that by 1. What about E?
well,
Max?
Is it just the same?
No, it's not the same. Can't be its own derivative.
Doesn't matter.
negative 3 over 2.
Negative.
It's just negative 3 over 2, right? Do you ever understand why that's negative 3 over 2? There's two ways to look at it. Number one, it's a line, so the derivative would be the slope of the line. Or number two, if you bring the, what's the exponent on the original function? 1. Bring the 1 out in front, reduce it by 1. X to the 0 is 1. It goes away. Good to go. Okay. Starting to click, yes? Okay, good. We did that. That's what we just did. Okay. Sum and difference. Real simple. Don't even need to write it down. The derivative of a sum is the sum of the derivatives. The derivative of a difference is the difference of the derivatives. Just like we've done with limits, just like we've done for everything. So if I want to take the derivative of this, I can just split it into individual terms. This is extremely helpful because now we can take the derivative of polynomials. If I have something like x squared plus 3x plus 7, I just take the derivative of each individual part, and what I'm done with is my derivative. Putting that in motion, are some of you writing this down, or can I go? Writing it down, okay.
Again, you just need the equation from all the written stuff.
See that? Yeah, right. One thing you'll notice is that there is no multiplication or division that comes later. That'll be fun. Okay. What's the derivative of that?
2x squared.
Maciek, you want to try it?
Yeah, sure. It'd be, well, you take the first term and you take the derivative of it, which is 3x squared. And then next is just minus 4 plus 5. 3x squared plus 1. No. I'm just saying. I'm simplifying it. No.
What's wrong with that?
Your factor 0.
Yeah, that disappears. That's your derivative. Derivative of a constant is 0, so that number in the back just goes away. Any problems there? So again, we can take the sum and difference rule and break that up for a polynomial, take the derivative of each term like he said, and we're good to go.
Wait.
I'm not going anywhere. It's okay. Let's give you that one now. By the way, that's negative x to the fourth over 1/2. Or sorry, over 2, which is negative 1/2. If it's a little clearer, you can do negative 1/2 x to the fourth plus 3x cubed minus 2x. Okay, Matt, what's g prime of x?
I'm not sure.
Break it into terms. What's the derivative of the first term? This guy. That's a half, by the way. No? Ashton, you got it?
Negative 1/2 x to the third.
No.
Wait, is it negative x?
Negative 2?
It's the same thing as negative 1/2 times x to the fourth.
No, I'm asking the whole thing is it negative x to the fourth over 2 or is it?
Either one. These are the same thing. I just rewrote it a different way.
Alright.
You missed something, Ashley. Take the exponent, move it in front, times the coefficient.
Oh, so negative 2x to the
Negative 2x to the third. That's the first term. Second term derivative.
6x. Wait. Oh, 9x squared. Minus 2.
Good. Okay. Bring the exponent down first and multiply before you subtract. Notice what's happening each time. We take a cubic, and when we take the derivative of a cubic, it ends up as a quadratic. You take the derivative of a quartic, it ends up as a cubic. So what you should realize when dealing with polynomials is we're reducing the degree of the equation every time we take a derivative. Okay? I think we might want to stop there. Let me look at the rest of these. Stop putting a dot on the board. Yeah, we'll stop there for today. Okay, now, I didn't necessarily break up the homework assignment knowing that this is where we would stop. So if you get to some trig stuff, hold off until tomorrow. We're spending 3 days in this section. This is how important it is. I just want to make sure that you understand the basic mechanics of taking derivatives before we start delving in all kinds of weird stuff. This is day 20, correct?
Yeah.
Do the parts that you can.
Oh my goodness.